Okay, so let's get our wrap up going. So this is what I said we would go over. Recap delta functions, practice taking the Laplace transform of them, and then talk a little bit about those periodic functions that we only briefly referenced previously, and do examples of both those things. So we recapped what the Laplace transform, or what the delta function is, brought back this idea of it being a limit of a piecewise constant function as the pieces get increasingly thin, and talked a little bit about how you can treat the delta function like any other function, which is going to be useful when you're building terms in your project that use the delta function. And then we just did a little example of taking the Laplace transform of the delta function, and then we plugged that same exact term into a differential equation and talked about that differential equation's meaning of being an undamped spring to kind of build intuition for what our solution should look like. And then we went through the steps to solve that differential equation using Laplace transforms. And we found that using the delta function in the forcing term for that spring introduced a term that used a step function after the delta function occurred. And we talked a little bit about why you might think that's physically reasonable, and then why it makes mathematical sense in terms of solving ODEs just being integration, and the integral of the delta function is 1 when you run over it. So after you've run past it, you turn on a step function that says, I've integrated over the delta function, and now it's always 1, or whatever it was multiplied by. And the reason I emphasize this is because if you have delta in an ODE, you need the step function to undo it. And then we did a little example with periodic functions where the only trick was just that we had to pick out our period and then represent our function along that period and set up our integral accordingly. And then we did that integration. And then after we covered those two new topics, we went back and recapped why we use Laplace transforms, the types of differential equations they're useful for, and then talked about the challenges with them. And then there was this like 15 minutes where I just talked about everything we've already done, so there was nothing new, and when we use these specific properties of Laplace transforms. And I'm not going to go over those again because all of it was a review as was. So here I've written up the wrap up as I understand it. We talked about what the delta function is, talked about how to take its Laplace transform and how you undo it, take the inverse using the step function. We did our periodic example, and then we recapped Laplace transforms. So your practice problem for today is to solve this initial value problem. Y prime minus 3y is equal to 3 delta of t minus 2 with y of 0 equal to 0. So it's a first order problem. It shouldn't be too difficult. If you run into like algebra issues though, just set it up and then kind of think through how you would finish solving it afterwards. So go ahead and get to work on that, and I will see you in class.